So I kind of wanted to go over some automation framework design stuff because there's been a lot of questions around it. I think I've seen at the conference and other jobs that ask about kind of how frameworks are built versus kind of the record and playback. So I thought I'd kind of talk about that a little bit. And I was wondering, by a show of hands, how many people here are QA, actual QA engineers? And then how many people are developers or programmers? Oh, okay. So maybe about 10%. Another kind of quick question is, how many QA people have a computer science or information technology degree? It's a smaller amount. And then how many do not have a customer or computer science or IT, more business or other? It's interesting. Okay. It's kind of interesting because I started out in QA. I didn't have a computer degree either. I started out in automotive and construction. So, and I got into it and then started taking classes for computer science. And I think that has a lot to do with how people develop frameworks and how well those frameworks actually work based upon kind of your background and where you come from. Like I said, I started moving into the business side and then started learning the technology, and then got into QA and then started kind of learning a little bit about IT and programming and development, and then I kind of found my niche with the frameworks. Let's see. So let me go forward. This kind of, the way I look at things is that QA people have kind of an idea of what they want to test and how they want to test it, but they have trouble building these frameworks because a lot of them don't have the technical skill set. Especially if you do a lot of manual testing, you kind of forget maybe the programming classes you took in college or whatever. And so that leads to some problems when building frameworks that work. And then the developers usually have a lot of technical skills and focus on testing in isolation more, versus end-to-end, broader scope. And then so that makes it difficult to build an automation framework that suits the needs of QA. And at the Selenium conference, I was really interested in hearing what Brett Petticord said about, in his keynote speech, about the science of testing and automation. And I could relate to it over the past 11 years, the same type of problems. That there's kind of a divide, as I call it, between QA and development. And it's really propagated by third-party tools that are not open source, they're proprietary. And it makes it really difficult to build a decent framework and expand it out to the community. At least that's my background and what I've seen. I think the open source tools have made a big difference in bringing development and QA together to actually solve problems with building frameworks and building more robust ones and solving more problems. So this, just real quickly, I'll just kind of, what I've kind of seen over the past 11 years at different companies is different phases of where people are at in automation. The first group I see mostly starts out doing kind of record and playback, do a little bit of looping and basic conditional logic, a lot of static data, the UI locators for how to find things on the page. It doesn't execute iteratively. What I mean is the test can't loop through itself over and over and over again. Not a lot of reusability. And tests that are chained together as dependencies. So one test executes, test A executes, then test B is dependent on test A, test C is dependent on test B, which is really, really bad. And there's not a lot of configuration and properties that are passed in. And then you can't abstract your test scripts away from your test tool or the test runner itself. This is kind of a basic test script. You can see all the Selenium commands are static data. static ways of identifying objects on the page, and everything else in it. You can't really do much with it. What's causing that? The next phase I've normally seen is that people will take those recorded scripts and they'll try to data drive them. They'll add variables and arrays to store data in. They'll parameterize functions or methods to store the data. And then they'll try to add looping. So they'll write little for loops or while loops inside the scripts to loop through the data to allow it to kind of iterate. Generally, it seems after that, it improves by QA folks usually write kind of a business function library, and to make things a little more reusable and modular. They'll add some file readers so they can read parameters in from different formats like text files and CSV files, spreadsheets. Then they try to abstract out the data by putting the test data externally, get it outside of the code, and so that people can manipulate it from business groups or whatever. And then they'll try to create parameterized tests that are data-driven. Then they start creating UI maps that are external to their code, get them outside the scripts. And then they start creating global properties and config files. But one of the other problems is what you end up seeing, or what I saw, is huge disparate data pools and UI maps where there's just hundreds of data files and hundreds of UI maps. And then it becomes really unmanageable and it starts to get really messy to maintain. And then your automation team grows exponentially to keep up with the mess. And then later on, like this kind of a late 90s thing, the whole keyword-driven library. And then using ODBC functions that reads the data from spreadsheets, reads the keywords, and kind of a domain language from the business side of things, so business people can read the keywords in those spreadsheets and kind of understand them. And usually the low-level keywords describe some kind of test operation, and then the high-level ones are kind of business-type language, domain language. And then the intermediate ones do all your kind of mapping between those functions and test operations. So at that point, the tests start to become readable to the business people and to the QA folks that are just not really programmers or not technical. And then you start seeing spreadsheets of data. And then they eventually start querying the application database for input data and verification data. And then there's kind of a hierarchy of these keyword spreadsheets. And then the non-technical QA folks and business analysts start helping to create those automated tests. But again, it kind of propagates this keywords, spreadsheets, data spreadsheets, or whatever. And a lot of the third-party tools definitely use this style. They've kind of built on this, and they've wrapped their legacy languages around it. And a lot of those aren't really compatible with the new technology, like QTP. Then later on, as the QA folks become more technical, maybe they study more programming and work with developers, they start using object-oriented testing techniques. And then they start to further modularize, reuse the code, and they start reducing the maintenance work. Test code is stored in objects using things like page object design, component objects. Test data is stored in object, and configuration properties are stored in objects. And then calls are made to the app to different APIs within the application to make the tests themselves smarter. Start using continuous integration. QA gets into white box testing more. Tests can be ran headless without having to use a browser so they can execute faster. The test framework expands where you can use more than one tool. So although Selenium is fantastic, you still may want headless tools. You still may want load tools. You may want all different kinds of tools, and you don't want to write your code twice to accommodate a different tool. And I went down that path a lot. You know, one for Silk, one for Windrunner, another for Robot, another for whatever, Load Runner, whatever. And so you want to try to share as much code and data as possible. So To do that, then you can start using web services and database and APIs that you can reuse for all your test tools. And then you can use third-party utilities and test tools to make things even better. And then at this point, developers can jump in and start using the tests, and it's not just a QA thing. Then it's more collaborative. And now we're starting to see third-party tools starting to use regular object-oriented programming languages that everybody else uses, you know, like starting to use Java or .NET. And so they're trying to expand out a little bit. So what's a test automation framework? I look at it as it's an application that lets you write a series of tests, and you don't have to worry about the constraints or the limitations of the underlying test tools. Anyone that's ever worked with a lot of automation tools knows that there's limitations and you can't do certain things. And so the framework kind of allows you to go beyond those boundaries of the tools. A test framework should probably be tool agnostic so that you can abstract away from the low-level commands like you saw in that recorded script. You should use mini tools like Selenium or WebDriver or HTML unit or whatever. Then use different test runners. You can use unit test frameworks or anything else. And then you can use other common utilities that make life easier. Like say for Java, you could use Mockito or Fest or some of these other little utilities that make life easier. Then you can also do multiple levels of testing, not just regression or functional, but you can expand it for load or unit or integration. You start building kind of a generic test API. It's a common code base in a database. Does your exception error handling. It's modular, it's reusable. And the main thing is it becomes maintainable. You know, you got thousands of tests and something breaks, you don't want to fix thousands of tests every release. That's horrible. And then the other thing is you want to kind of standardize test idioms that are specific to testing in QA. And that's what I'm looking for. Test configuration, you can configure your test suites. You can have global test properties that you pass around as objects. And another problem that I see a lot of is test versioning. A lot of times when you start having all these parallel environments, all your environments tracks are running on different lines of code, different versions, and you need to run your automated tests across all of them in the same day. And then your tests start to break, your framework kind of breaks down if you're making it version specific. You need to check it out from your source repository, copy it, download it, drop it onto some other machine to run it for one environment, copy it, download it for another machine so you can run it against a different environment. And it gets to be really, really messy. And then if you have people coding simultaneously across different versions, you start ending up with a mess. So it's easier if you can just deploy one version or one framework where you include all your versioning and just deploy it to your machines, just get the latest and not worry about it. Multithreading. A lot of frameworks can't run tests in parallel, so you can't really gain any value from your execution time, especially if it runs sequentially. It takes 40 hours worth of tests have to be executed because they need to be run in sequence. If you could run them in parallel, you'll be done in a couple hours. You also want to test across multiple environments and these different versions simultaneously. Continuous integration, you can put it in your CI environment, run your tests for every build, and then you can share your tests and collaborate with dev and other teams. This is kind of the high-level view. So enough of the, there's not going to be as much words in here now. There's going to be a few more diagrams and some more code samples. This kind of describes a little bit of a high-level view of how I design my automation frameworks, where you have your test configuration here, which is externalized from your framework. So if you want call application databases or web services or other external things. You stick that off to the side and external to your framework, and you can call it. That way you don't cause any SOX compliance or regulatory problems by checking that into your repository. So you can externalize that, and then your test suite is externalized. And then you have your test script library that calls more of your test library, so your scripts are a little bit smaller. And then your test, kind of your test application, the runner for that executes against whatever your test runner is with inside kind of your core framework, which could be NUnit, JUnit, TestNG, whatever. It doesn't really matter. And so I usually separate things into 2 layers. I have what I call my core framework, which is application independent, tool independent, organization independent. Doesn't matter. Then I have, get my mouse show up. This is more what I consider the application, the organization layer of the framework that builds on top of that or uses that core level. And that's the one that tailors to your application, your company, your data, whatever you need for your company. So everything in this kind of outer area, the organization-specific framework, points to this core framework that's kind of generic and provides all the low-level, difficult stuff that you want to kind of abstract away. So you don't have to use it you don't have to look at it, and you don't have to mess with it. Mouse is disappearing. Oops. So at this point, I usually have whatever my test runner is, JUnit, TestNG, NUnit, whatever, and it's, I'm sorry, my mouse kind of flipped off. So I use the tool for whatever my test runner is, and I have a little framework specific to running that. My mouse doesn't work good, I apologize. So you can't really see it, but in the bottom right corner, and then I have kind of the data access methods and utilities in there that call my test data repository, which could be anything, XML files, web service, database, whatever. And then the other piece I'll have is in the middle is where your test tools are, and you kind of have your test tool framework that utilize whatever tool you want, and then your lower level framework services, and then it points to your parameters that relate to your test data, your properties that are coming from your configuration file, all those global properties you would want to know, and then the kind of controls, I call them controls, but they point to your UI locators or your UI identifiers. So that kind of extends out, and you can see at the top middle there's a test data gets fed into the script, and it's also used inside the application layer, what I call the services part of the framework that's being used. That's the API itself. And then there's kind of a container that I wrap around it. And then when I execute the test runner, it launches a separate thread of the framework, and it loads that whole framework into each individual thread. So each test can run in parallel, and it's its own instance of its own framework, and it can represent whatever it is that that test is supposed to do, which kind of makes your morphs to whatever the test case scenario is for your application. And then you can call, get your application data from your application database if you need to query it for specific data, which is something we use heavily at Williams-Sonoma, and then, or any other service, you call an API or web service or whatever. So that's kind of the overall way that I build mine. And so a test suite, it's a collection of tests to run, has parameters. The main ones I use are the application name, the environment, and the version. The version to me represents a release version. You could have many versions as you want, subversions, builds, whatever. But for me, I need something that kind of identifies one release from another, that I'm running, let's say, 8 environments or 10 environments in parallel. Each one is a different version. I designate it somewhere in the framework so I know what it is and what the differences is. Then we, different test groups, regression, build, integration, whatever. So in this case, I'm using an example of TestNG, and you can see there's parameters specific for Selenium to run, which would be the server, host, and port. Then I designate the test tool. It could be Selenium, it could be WebDriver, it could be HTML unit, it could be whatever. App name, the environment, the version. And then the build, the operating system, or well, the build, it's more for informational purposes, so you can keep track of your build. The operating system and the browser name, and I'm missing one, which is the browser version on there. It's a little old. But then you call that out, and then you can tell the test script class itself, and then all the methods. Those are blown out, but they don't have to be. They can be consolidated. And so we run our tests in parallel. Actually, we run them down by the class level in parallel. So test configuration, anything that you need to put external that you don't want to check into your source code repository, I stick in a test configuration file. Website URLs, databases, usernames, passwords, lab machine configurations, all that stuff is separate from the test suite. It sits outside the framework and it's just called and read in. Here's an example of this is what I put on my local machine as an example. I have my environment information that has to do with my server, the automation database, all that stuff is here. The client machines, what those are, what the browser OS combinations are. Test properties, these are tailored to every thread that runs in parallel. They have global scope, can be accessed anywhere, and they're just passed around as an object, essentially. One object that's used globally. Here's an example of the interface that I use. This is probably about a quarter of the properties that I use globally that are passed around. Application names, not so much the URL, that gets built. The browser names, types, database URL, environment, OS, test configuration, file path, test names, tools, and then the path to the UI maps, kind of the base level UI map path, and then the version. Test data repository. This just abstracts away all the test data, so you can make changes to it without affecting your code, without affecting your UI maps, all that kind of stuff. And we personally use XML, and we use an Oracle database to store our data in, but it could be in any format that you want. You can read it in with some utilities. You can retrieve data from databases, web services, APIs, whatever. Then we use metadata to describe information about that test data, like what application it applies to, what version that it's running in, so we can separate versions and reuse versions, what's required fields, invalid, all that stuff. And then we can share that data across multiple screens, pages, applications, and different test tools. So here's kind of a little example of an XML one where my class is search flights. I describe the structure, and then I can translate it to different languages if I need to. I can put a version in here. I don't have the whole thing here, but there's another layer where I describe the version. The properties are passed in, it reads that, and then it looks at what version the data is, whether it can reuse it or not, or if it needs to be version specific. And then it tailors it to whatever class is going to load that data in and use it. Parameterized tests. This is a real simple example of a real basic class using JUnit 4 and TestNG, where they both use, I use a data object where I store all my data. Let's say names, address, phone numbers for a specific page or series of pages that use the same kind of data object. And then I use a DAO to access the data, whether it's reading it from a file or whatever. And then the path, let's say, to the XML file. So this right here actually works, but it's super simplified. And you notice kind of the parallel nature. So this is Java. Obviously, this framework I'm using is written in Java. So the JUnit 4 format uses a collection of an object array to store the rows and then all the fields. And then the same thing's happening in TestNG on the right, where it's using a data provider, and it's just it just calls out and it stores it in a multi-dimensional object array. And then you can pass that data in. With JUnit 4, it iterates at the class level. So for every row of data that you read in, all the methods share that exact same data, and it reinitializes the class over and over. TestNG I think is much better because it works on the method level. So you could have multiple methods with multiple test data providers, and each method could have a totally different iteration, totally different data than the other methods. If you had 10 methods, they could all have separate data providers, and they could all iterate completely differently from one another. And normally we bury this at a really high level, the functionality, so we can iterate on methods without worrying about the data being passed in. We just use objects and find out the iterations. Test parameters, I usually use a hash map of key value pairs so that I can use it for both functional and load testing. It eliminates the need for me for having fixed method parameters because that changes constantly between versions. Changing data access objects that change frequently, so if those parameters, those fixed parameters change, so does usually the DAOs. So I don't want to have to mess with the underlying DAOs, so I just use a hash map at the bottom. I can populate them pretty easy from different data sources. I can retrieve that data and process it for input to different tools, not just one tool or another. And then I can handle version differences. Here's kind of a test parameters. This is the interface that I use, and you can see it's just basically a map, or basically a hash map, and I just set all the values either as a series of objects for the sake of TestNG and JUnit 4 for the iteration, and then the map I use as the internal parts of the parameters are used inside the method. So I can query inside the method, I can query for as much data as I want from as many places I want and pass that around. But the iteration part I use on the object one here. And then it just clears them. So UI mapping, just kind of, I try to abstract away the changes that are made to just the UI itself. So if I'm changing the locators or the identifiers for different objects, I can do that away from the code as well, just like the data. They can be stored in any kind of format as well, just like the data can, databases or files. Then you can use metadata to describe the same way, versions, applications, it's a form field or not, whatever you want. And it's real flexible. And then you can use it everywhere. Here's an example of the schema that I use for an XML schema that I use. So I can designate a class, which is really the container. It can be a class, it can be a method, it can be a component, whatever I want it to be. And inside of it, I have all the objects. And then I name them, and then I kind of use a generic tag names for me, like IDs, or I call it CSS or XPath or whatever I want to use. And then it's not tool specific. So if Selenium 1 or WebDriver or HTML unit, whatever, I can use the same identifier across all the different tools. And then it's versioned as well. So like there's a couple examples here where, get my mouse to work, like there's a version 1 and version 2, and it'll pick it up. Then test controls. So the test controls usually get those UI locators and process them for input to whatever those tools are. So it's a series of, it's a class that just reads that in and passes it around in the right format to the tools. It handles those version differences between the UI locators. And then I can develop custom controls to mimic the UI objects. And then it can self-test and verify itself. So the nice thing is when you have different versions, and let's say I have one screen that's changed, but all the other screens haven't changed. Let's say it goes from version 1 to version 2. If I specify version 2, globally the whole framework sees version 2, but only that page of version 2, it reads in those changes and acts on that. Same with the data. But the other screens default back to the previous version of 1. So it runs on the current version, whatever's out there in production, whatever your base version is. And then whenever you only have that version change, it always jumps up to the latest version, no greater than the one that you're asking for. So here's kind of like a basic interface. And I was looking at this more from, like say there's a type control interface, and then below I have an HTML input text interface that I use that inherits from the type control. The idea here is that I could use this for more than just web testing. So this framework could morph itself to whatever tool I'm using for whatever interface I'm using, whether it's web, you know, client server, whatever, and use some of the generic stuff and then make it more specific to whatever type of application I'm testing. So in this case, I'm checking for like minimum, maximum lengths, the masking format, looking for valid and invalid characters and digits. And then the HTML input text would inherit an input, HTML input interface, and then the type control, so it would morph to a web style text input. So like here's kind of an example of what I was talking about, where on the right side is the class that's implementing that interface, and it's reading that type control object in, and it's using it to type things, to call the SelfVerify, getting the different, it's implementing all those different interfaces. And then on the left side, this would be the implementation of the type control class itself, just a short segment showing where the SelfVerify is calling to test the minimum length, the maximum length, and this is where it actually does the implementation. So if I needed to extend it, something that's HTML specific, on the right side I could extend it or override the parent type control, so to speak. Test components. This is a class object that represents a piece of a form, page, or screen. So you can cluster groups of common objects that can be found across more than one page and standardize those component verification tests. So very commonly, we have multiple pages and forms that will use a lot of the same objects and are clusters or pieces of objects, maybe a set of radio buttons, maybe a set of input fields that are common across all kinds of pages and forms. So we'll create this little component and then we'll call it from the form or from the page itself. So that would be like this example, like say a form component. It's extending from a phone component class that's extending from a form, and it has the little control specific to the form itself. So we extend this form control class, and then we have the HTML input text for like say home and mobile phone numbers. And then we have the parameters that are specific to those. And then let's say we call a fill form method, and then it populates. It does the work of typing and passing in the parameters to those types. And then test forms, that's a class object that represents, represents a form, not a piece of a form. And then groups of components and controls that mimic the UI form. And that's so I can allow some standardized form verification tests. So here's kind of a piece of a form interface. Again, it's trying to standardize some of the method calls that I would use in any form, like filling out the form, submitting it, filling out all the fields except for a list of names that I want to exclude, fill them, submit it, then cancel it, a whole bunch of other verification methods that I would use that every form would do. They may implement them or they may not, depending on what the form is designed to do. And then here's kind of the example of a class where I have filling out, submitting the form, filling it out, submitting it, and they're calling each piece individually. And so these are kind of like high level. Like you see the fill form, it's implementing the interface, but you can override it for whatever your form needs to be. So something like fill and submit form, those operations are kind of common. I can declare that, write the code once at this level, and this is an abstract class, and then a very specific form could override the fill form and fill it out for whatever your form looks like. So that way I'm reusing as much code as I can and trying to standardize the names I use. So here's an example of where I'd have kind of this personal information form. I could have an address and a phone components. I call those out, and then when I fill out the form, here's where I override that abstract one, that abstract method, and I set all the parameters, fill out the form, and so my code's fairly short and it's reusable. And there's an example of verifying all the error fields. So I have it all declared in that component, and I just call it. Test page or screen, this is, you know, the typical page object, class object that represents a web page or screen. Can have multiple forms, components, or controls that just mimics it, and they can do some self-verification. This is kind of a bad example. I couldn't think of anything really original here. So it calls the form, uses it, and then it can verify basic things like page URLs, headers, and titles. And then I thought this was kind of important. There's a lot of talk about using page objects that return back brand new pages and as objects, and then sometimes I found that this doesn't work really well. Like for example, at Williams-Sonoma, we have some pages that always return back. If you make a call, let's say go to the customer service page, it's always going to return a customer service object, page object. But there's other places where when we're in a kind of our shopping cart path, when we're purchasing items from the cart, where it won't return back one page. You can get a series of all different kinds of pages. And it may not even be a page. You might get back some AJAX thing that just morphs the page and transforms it to something totally different. So if you make a call to expect one object back, you may not get the one you expect. So using page objects can be kind of a pain if you expect them to always return back another page. Sometimes you need to change it a little bit. An example would be page A could return B, C, or D, but it's based on some conditional logic. Or it could return page B, but in different versions that look completely different than one another. So you need to be able to handle that stuff. And how are you going to do that, you know? So I try to show an example of what I've seen other people do is where you create page A, but then you're going to submit to B, submit C, and it's going to return back page B. It's going to return back page C. Well, if you got a page object that could come back with 10 different pages, then you're going to have a whole bunch of methods that resemble each one of those pages that could be returned. And then it's kind of a problem if you don't know which one's going to be returned. Another thing you could do is return a page object of an inherited type and then cast it afterwards. So the submit returns page X, but B and C inherit from page X. So then your script needs to check which type it is and cast it to the appropriate one. So if you do this in a lot, your script can look kind of ugly and not very readable. Another thing is you submit a page and you get an AJAX call, rewrites the page. You may get a modal dialog or who knows what, or some other AJAX widget. And you could actually have the page be rewritten using AJAX to look like a completely different page. So you wouldn't want to return a different page object in that case. You just want to be able to handle it somehow. So if your page flow is not what's being tested, let's say you want to get from A to Z, but along that path, the primary flow, like in this case, A to B, B to C, C to D, and then D to Z. But your alternative flows could be like the ones listed below. and they're based on unknown variables that you may not know how to resolve. In that case, we have that problem at Williams-Sonoma where we don't know exactly what data or what situation might trigger these different pages to come out. And so if you hard code your page object, only return one or the other, your test is going to fail. It's going to die. And it's not going to be very flexible, and you won't actually test condition Z, which is what you're really after, and you'll be spending more time trying to figure out how to get through to Z. So if you get these unexpected pages, you're not going to know what to do. And then it's going to assert a failure, and you're never going to get to the end test that you're after, test condition you're trying to achieve. Another thing that I see a problem with is you need to use JavaScript and HTML, especially for web forms and web pages, where you need to know something about the page and what a human being will interpret on that page. So a human being will look at a page, maybe a list of search result page, and they're making a decision on what to do with that page. So you know intuitively, I look at this row and maybe 5 rows down, I'm going to click the edit button or the update button or do something. And automated tool doesn't know what to do, has no idea. It only does what you tell it to do. So you have to put some kind of logic, some brain in your framework that tells it what to do, how to read that page like a human being does, and then act on it. And one of the problems that we have at Williams-Sonoma is that we have a web content management system, and you can change your page changes frequently with whatever the content management system displays. So your data is changing, the format of your pages change all the time, and a lot of the elements that are displayed on the screen are dynamic. They're data-driven. Whatever data is being loaded into the system for that build can totally change the way your screen looks. And so you won't know what it looks like at all. So you have to have some way to be able to determine what the test is, what's the human going to do, what are you trying to do, and mimic it through your framework. So for me, all these problems are solved by using JavaScript and going through the DOM and figuring out something about that page. So if I wanted to have it query an application database or web service, get me the input data to trigger this dynamic page content that's changing. Then the test framework would need to look at the page, inspect whatever it is, the element, the attribute, the content, and then make a decision on what it should do next based on what's being displayed. If what you expect to be there, say you're verifying something, doesn't appear, then you fail it. If you expect some element to appear and it's there, then you act on it. If it's not, it fails. But you need to be able to figure it out so you can determine if it's behaving properly or if you can move to the next step and how to handle it. I use JavaScript a lot to inspect the DOM to find these elements. Those JavaScript expressions can be evaluated by the tool and then return some kind of result that your framework can use to make that decision to mimic a human, what the end user would actually do. If you just check for see if an element's present or get a value, doesn't work really well when you have dynamically generated elements and content. Usually causes a lot of problems. Your tests will usually fail because sometimes, like there's a bug, let's say, in Selenium 1 with IE. If you call for an element a couple times, it's not there because it's dynamically generated, it'll puke. It'll throw an error up and it won't handle it. But Firefox and Safari will handle it more gracefully. But just doing those aren't enough. You need to, maybe you need to find out an index or something. So here's a little example they use like on Amazon where there's a couple books in this line items here. And I use Firebug. So I don't know if you can see this very well or not, but there's a div with an ID. In this case, I wrote the JavaScript, and basically I want to find out something about what ID each one of these rows are. So if I just do a search for some book, I don't know what order that book will appear in and what the identifier is for that row, so I can find that book in that list. So a person would look at it and go, I search for this book, it's going to be in, you know, in the second line item out of, let's say, 100, or the second row out of 25. automation tool won't know that, so you gotta have some way to look for it. So I'll pass in the parent ID that tells it to look at the parent div, and then search around and find that, like maybe the book number, the identifier for it, find that, and then return me back the row ID so I can figure out where it's at in that list on that search results page, so then I can do something with that, either verify it or click on something or whatever. So here's an example of the JavaScript for that page that you could execute, and it'll come back to tell you what the ID is for that. And the only difference is, like if you're using Selenium 1, the little highlighted part that I have here is the only thing you need to add to that JavaScript in order to make it return back the value you want and run inside of Selenium 1. We use this stuff all over the place to make those kind of decisions in a framework. The other thing I use is an application container that kind of mimics what the application would do, and it's just another class object, and it contains all the major pages and components, not every single one throughout the whole that represents your whole framework, but just the major pages like customer service or whatever. And then it provides all those test services available to the test script so they can do something with it. It's also thread specific, so every one of these containers is launched in another thread so that each one's unique to whatever your test is. An example would be kind of like, here's my interface, and if I have two major pages in my app, let's say the search flights and select flights, this is how I would use it. And then this also contains my versioning. So I could launch different versions of my classes that represent different pages at different times in different environments or whatever. And then it calls it here, and then I launch the version that I'm actually trying to test against. Parallel environment tracks and different build versions. This is what eventually led me to doing this, was that we have so many development tracks. It's like you start out, every company, starts out with one. You start out kind of small, dev, QA, UAT, and production or whatever. Next thing you know, it propagates into 10 different environment tracks with a zillion environments inside of it. You got 100 developers working on each, and they're divided 10 on each track. And so you've got all these things happening at once. And the automation has to be able to run build verification tests across all of those. Every time they check in a build, you'd want it to launch your continuous integration, verify that build. You also want to run functional and regression tests on a regular basis on these different environment tracks. Maybe run UAT tests, run tests for production packages and fixes. They're in different versions, and then run sanity tests after you deploy to production. And then there'll be cases when maybe you need to roll back your application and you need to be able to test the version we pushed and then the version we rolled back to in case it fails. So this kind of little graphic, simple one, where depicts kind of what I've seen in a lot of places where you maybe have a really slow track, pushes from development to continuous integration to QA to user acceptance, hits your staging, and then it goes to production. And you have a fast track for things you're going to push like in, say, 2 weeks. Slow track for something that takes 6 months to a year. And then your regular tracks for something that's only going to take maybe a month, 2 months each. And they're competing to get to production, where I've seen these regular tracks where they kind of know, well, we think this will be version 1 or 2, 3, and 4. But, if something stalls, we'll push one above the other. And if one runs late, the schedule slides, we'll push the other in its place. So they compete, and in the end, one may go, one may not. You don't know which one it's actually going to go. It doesn't always follow the milestone plan. And then other times, you'll have something that goes to production, and you got to roll it back, and it falls all the way back to development, and another version goes in forward. And then other times you'll have like this fast track, maybe 2-week things, or maybe they're patches or fixes that's got to go every week or every couple weeks. And so having your automation framework deal with the different versions and different environments will allow you to run them in parallel. Test scripts just can use any standard unit test framework or any kind of test runner. And there are classes and methods that can be written to use kind of a domain language so that other people can read them fairly easy that aren't very technical. And all the details and the complexity are abstracted up and out so that the scripts themselves are shorter and easier to read. So like that original script I had that was recorded, this is more or less what my end result would look like, where it's just really short, it's really simple. This test script could iterate 100 times, and then it'll just act on, filling out one form of one page, submitting it, and then going to the next page and selecting something and submitting it. So it could be really short, compact, and a little easier for people to read. Then, of course, with your own framework, you could do, your reports could be using your unit test framework, any other reporting tools, any other custom report utilities, and then you could write all the activity to a standard logging utility, and all your failures and errors and exceptions can be written to your reports and logs, and you can find it. So it's not tool specific, in other words. So that's really all I had. Thanks for your time. Any questions or anything? So the question was test the versions that I'm referring to different versions of the application or different builds, different branches of code for the application. That's exactly what I mean, yes. Okay, so the question is, the test framework is not branching with the application itself, right? With the code from the application branches?
Is that correct?
It's yes and no. So it does branch off with the application, the different branches of the application, but it's version. So I tag it with a version, and so everything I check in contains all the versions at once. And then when I pass in a version parameter for the configuration for that test suite, that individual test thread will go in, read to the framework, and it'll use that version that applies to that branch of the application itself. So it's like looking at all the different versions that your application can go through, all the different branches your application can have, and it's stored all in one framework at once. So if I pass it version 1, it'll conform to version or branch 1 of your application, or the trunk. And then version 2 would resemble like a branch off of your application that's going off in this one direction, whatever it might be. And then another branch of that application that's going off over here would be like version 3. So I could pass it in that version, and it'll automatically morph the framework to match that branch of the application. So it does follow the branch, but it contains all the branches at once. So that way I don't have to like check out from the source code repository all the code that would kind of resemble that version for, let's say, branch version 3. And then check it out to another machine that matches branch version 2 of the application. I just tell it a version. I can kick it off. I can pull down the latest from the source code onto whatever my test machine is, and just pass it the parameter that says it's version whatever. And it'll go out and morph to whatever that branch is, and it'll test it. So that way I could take one test suite, point it to multiple environment tracks. Like say I got 10 environment tracks, and I want to run that same test against multiple browsers and versions, and each one of those tracks is a different application branch, and it'll just act on it, and it can run it simultaneously in parallel. Does that kind of answer your question? So the question is, if I consider the difference between checking in versions of the framework into the source code that matches the branches versus putting it all together, and is it kind of messy or whatever, having it all together? Yes, because in the past I've done that where I followed the application branch, but when you have people working in automation on all those different versions simultaneously and checking it in, I've found it to be a little bit hard to keep track of each one of those branches when everybody's checking in, and then you got to pull it out and deploy that version off that branch that matches that application branch, deploy it to this machine, then deploy it to that one. And I found that it starts to get kind of hard to maintain. Whereas instead, we just check in everything at once. Whatever version you're working on, you write the code and check it in. And then I don't have to keep track of different versions on different test machines. I just deploy whatever's out there, the latest version, and just run it. And then I don't have to worry about kind of that maintenance. So for me, it actually works better. But I have less maintenance, and I don't have to worry about checking out versions. I just check everything into the trunk all the time. Just get the latest. And when it's versioned, it's not really hard for me to follow it. So I find it's actually less work for me, less maintenance. The question is, how often do you find bugs in the test framework that's not the application bug? That's all the time. I mean, there's always that factor because I'm coding something myself. So it's prone to just as many bugs as a developer coding the app and making bugs. So we have to routinely run our tests and make sure that they're working right before we ever do a real run of something. We always run through tests to make sure it's working properly and debug it. So that, yeah, that's normal. I don't know if it's ever possible not to have that happen. Yeah, and we try to put in some, I mean, yeah, when there's a case when everything passes, you're saying, then you know it's the test framework's not the problem and it's the application. There's always that self-verification. Is the test giving a false pass or is it really a failure? I mean, that does happen. So, I mean, you have to, for us, we try to put in some verification steps. And one of the things that I've been trying to work towards is to create sort of a stub, a dummy tool, where I can run tests without invoking the application every time, that just basically unit tests my own code. And then, but a lot of it is, you know, running the test, making sure it's right, that it does what you expect it to do before you run a full execution. And if there is a failure, you want to make sure it's, you know, a real bug versus the test framework. So the first place I always look is to the framework for a bug. I always do, before I go looking at the application or the data or whatever, the environment. So if I'm using JavaScript to inspect the page where it's dynamically changing and I'm trying to test the state of the application and then the test, and I want to make sure it's actually giving back the correct result so that I can test what it is I'm actually wanting to test, right? Well, what we do for that is we test the one path that we're after or whatever, and then all that I use JavaScript for is to read the page. I don't actually want to trigger anything in the application to change it. That's not the intent. The intent is just to read from whatever's there. So let's say, for Williams-Sonoma, an example would be like, I want to purchase an item like a towel or something, but I'm not really, well, that's a bad example. I want to test that something can have a monogram on it. So I query the database to find some SKU that has a monogram item or whatever. It could be a towel, it could be a sheet, I don't care. It could be a table if it was possible to monogram it. But I don't care what it is, and it comes back with a SKU, and all I do is look at the page itself and scan for that SKU number, see if it's there, and if it is, what line item does it occur on, and then return me back that line item, and then based on that, I act on the next step, which is do something, whatever it is you want to do. Click on it to select it, to purchase it, whatever you want to do. So it's not altering the flow of the test at all. It's just coming back and telling me where is the position of it. If it doesn't exist at all, then I assert an automatic failure to kill the test, because then I'm not testing anything. You know, I don't want to test something that doesn't exist. So I'll fail that, and then it's go and investigate. And a lot of times we'll find that there's data changes in the environment that impacts it, so the test can't actually run, and there's nothing that we can really do as far as the test is concerned. We can never actually test it because the data isn't right. So we need to tweak that. But it doesn't actually affect the flow of the test. It's just reading from the page to kind of mimic what you would do as a user. Go, I want this towel with monogramming, select it, purchase it. If it doesn't show up, then we assert it as a failure. So we never actually get to the condition of the test. How many people are working on the framework? We have 3 people working on it now. VJ and Jay over there are the ones working with me on the framework. And the development schedules? Dev release schedules? Oh, they're spread out. We do a 6-week release cycle. where every 6 weeks we push out new versions. And so we expect to do one version after another every 6 weeks. So ours is, we have 8 different tracks running in parallel, but they all have a timeline that goes fairly sequential. So, okay, so it's kind of a combination. There's a TestNG that does the parallel or the framework. The parallel or the framework itself does handle multi-threading, so we can invoke different threads, but we use TestNG, the test suite, so we organize the test suite as in parallel threads. We'll say all these classes are going to run in parallel. So it'll separate each thread, in other words, for us, and it'll call it, and it's the one that calls the framework to invoke each thread, but we have the code inside of it to make it run multi-threaded. Because if the framework itself doesn't handle multi-threading, TestNG doesn't matter. So if you're, let's say, if the framework itself is only written to invoke one instance of it and doesn't handle multi-threading, you could have the whole TestNG suite saying to run in parallel, but it will only activate one thread at a time and it'll run sequentially. So the framework, the way we built it, is that it doesn't matter what the test runner is, you call it and then it'll kick off a separate thread when it invokes. We just use TestNG to distribute the threads and call that mechanism, that multi-threading mechanism. Does that make sense? No, it doesn't. So the question is, do we use another tool like TestNG to call the framework to set it in parallel? No, because the idea is that my intent is to use different test runners abstracted away from the framework. So they're just calling the thread. They kind of like distribute, say, I want to open up 100 threads. Like TestNG is our suite. It says, I want to open up 100 threads. So then it just kicks off the framework, which executes 100 threads. TestNG itself isn't invoking each thread. The framework invokes a thread, but it's just the calling that says, I want to open up 100 threads, execute it. So that way I could upgrade any version of TestNG I want. I could replace it with, like, say, JUnit parallel or any other test runner that can run in parallel. I can use that to kick off the parallel threads inside the framework. So I'm not trapped on using only one test tool or one test runner. So I don't want to be limited by tools. In other words, I want the framework to just be used by whatever tool's out there. So I'm not tied to one specific thing. I want that flexibility, in other words. Does that answer your question? Okay, so it's how do we calibrate the timing of different objects on the page loading on the application? So, like, we use Selenium 1. We'll use a wait for page to load, and then we have a global property that just says this is the max wait time for a page to load. Typically, our test environments are way slower than production, so we can set it to say, you know, it's going to take 2 minutes to load a page because that's acceptable in the QA environment. You know, if it was production, you probably want it a lot less than that. But we set a global property to handle that. If it's like, say, an AJAX call, and you just, like, say, you click a page and you want some modal thing to pop up inside the page or something else, we'll set, that's, to me, is more page-specific calibration, where that page needs to load that AJAX faster, so I probably don't want to wait more than a couple seconds for that to happen. So we'll calibrate it to that specific page. But if it's globally, the whole app-wide, we'll say maybe we want to wait 2 minutes max for the QA environment for the page load because they're running on VMs and not, you know, not load balanced with its own physical machines. So something like that. So we use kind of global properties to tell it this is the max page load time for the whole app in QA. But for a specific page where an AJAX call is being made, we only expect a few seconds because it shouldn't take longer than that. So that's kind of how we do it. Anyone else? Oh, okay, so the question is, why do we use JavaScript as opposed to XPath or CSS to locate elements on a page? We'd use that. So we locate elements that way, but the problem that I'm talking about is like when you have dynamic elements being generated on the page. So instead of they're fixed, like say you go to a form that has name, first, last name, address, city, state. That's always there. You know that. That's pretty predictable. But for something that's dynamically being generated based on data, application data, and you have no idea what that's going to be from day to day. Let's say you get a daily build that includes different data set. Because at Williams-Sonoma, things are seasonal, based on holidays, whatever, so your data set's going to change radically all the time. And that data drives the way the page is displayed. So one day, you know, for one item, let's say a towel, you're going to have 2 radio buttons. For a table, you'll have 10. And for, I don't know, a lamp, you'll have no radio buttons. And so if you want to figure out where they're at, we still use CSS and IDs and all that, but those are dynamically generated elements, so they'll have an index associated with them. So the developers say, well, if it's got 3 radio buttons that represent, I don't know, maybe a color of the towel. So one towel can come in blue, green, and red. Another one could come in orange and purple, you know, whatever. We're not going to know that at all. The data is different all the time, so we're just querying for some attribute that says we need to test this kind of a entity. And then when it displays in the web page, it may have 3 different colors for 3 different radio buttons, but another object or towel or whatever may only have 2 colors. So we're not going to know where that's at. We only know that there's like a SKU number that comes back that represents that entity that fulfills the need of that test scenario. So when it comes up, we need to be able to find it on the page. So what we're looking for when we inspect the page is, where is that item at on the page? So if I've got 10 different radio buttons, they each represent a different SKU or something. We want this one here. Well, we don't know where it's at. It could be at position 0 or position 10 because it's randomly displayed. So we want to find wherever it's at. It may be in position 7. So the JavaScript is just to tell us where's the index of where that SKU number is found. And based on that index, we pass it into our CSS selector or our RD or whatever, so it knows where to find that element to click on it or whatever you need to do. Well, what I'll do is, like, generally what I see most developers do is give kind of like a standard identifier name, but then they'll put indexes in, or they'll put some attribute that's hidden in some element that they use to designate what that element actually is, that's specific to whatever that SKU number is or whatever. So I take the generic name and store that as an XPath or CSS selector and ID. And then when I use the JavaScript, it's just to find that element and figure out what the index is. And then I just pass that index into that CSS selector and build it so that it can go find it. So it's just more like it's a generic identifier, and I'm just passing in the index into it. I'm not doing even a contains. It's just, here it is, here's the element, it's in like a brace or something or bracket. And I'm just saying, for me, that's kind of the way we go about finding it in the page, to find some of these dynamic elements. It's not the only way, it's just one way that works for me. Some places I've worked at, they'll just always have a fixed one. You always grab the first element all the time. And that doesn't work in most companies. So for me, this is one way that I go and grab it. So where do I spend most of our time in building the framework? What areas of the framework do we spend most of our time working on? That's the question, right? I usually spend most time, or we usually spend most time designing the different components to make them reusable and modular. So if we're working on this page here and this page here and this page here, can we build those as reusable components that we might use somewhere else later on? I spend more time probably designing it than the coding part. The coding part's usually a lot faster. It's kind of that design of making it reusable that we probably spend more time on. And then as far as maintenance, I'd say most of the maintenance time is spent on the UI, changing things in the UI. So we'll maybe tweak the map or something to add in new elements or change elements that are changing between versions. So spend kind of a lot of time on that. The data part, where we go out and query the data from the application, because it changes so frequently and the system's so complex, we spend a lot of time making sure that those utilities that go out and query the database are accurate to get the right data and make sure that works correctly. And that's a huge chunk of time, because we'll spend a lot of time with the developers trying to figure out, this is what it's supposed to do. We're not using their same queries or whatever. We're trying to figure out a way to independently validate and verify it. So we need to know kind of how it's supposed to operate ideally, and then query it in that manner and make sure that works right. So those are probably the 3 areas I think we spend most of our time on. So question is, one of the slides is for why do we develop custom controls to mimic UI objects? What's the purpose for that? Well, one of the reasons is because, I mean, I've typically created you know, Selenium click, Selenium type, whatever, or the WebDriver version of click and type that represent different objects. But sometimes you have those complex objects that are, let's say maybe in .NET, where they're using a third-party vendor, and it's a combination of multiple simple HTML types that are put together to make it some special object that can do like drop-down edit boxes and, you know, things that are like a text area that has scrolling controls. That's not a simple HTML type, so we need to kind of represent it and test it. So one of the things that I've been working on is kind of like standard ways of dealing with those simple elements, and then where you could make more complex ones so that they could test themselves, and so you don't have to write the same code over and over and over again to mimic what an input box is and then change it for the different test tools. I can have one control that incorporates all the test tools that act on a text box the same way. So I just create like a text box control, and then all the tools, that object contains all the commands for each tool on how to click that text box or type in it or whatever. And then I can abstract away the tool itself. And then I could also, if I have some weird control that someone created, like say in a .NET environment and some third-party thing, I can custom build it on how it should behave and how to test it and all the commands in there on how to do that without having to write all those little things out for, you know, Selenium 1, Selenium 2, HTML unit, whatever. I can just create all that stuff, abstract it away, and then just call it and then just use it and pass different parameters on how that one behaves on that page. Is that kind of, does that answer your question? Sort of. It's just, don't have to do it. It's just one thing that I was thinking of that works for me to make kind of standardize something so I don't have to write the same code over and over again and just reuse it. Creating, or am I using different tools to test that or to drive those components? No, I just build it inside the framework so that it doesn't matter what the tool is I'm using, like the test tool, and it doesn't matter what the test runner is. So if I want to use JUnit, it'll drive all those components. Or if I want to use TestNG, it's kind of abstracted away from that. The test runners are on this side, test tools are over here. The components are built more so I can call an API. I want to call an API with all those components, and I don't care about what the test runner is, I don't care about what the test tool is. We just want to call that API that represents our application and how to test it, and then all the underlying details of the tool or the test runner are abstracted away. But writing unit tests for some areas, yeah, we write units, especially like, for example, the component that calls our database and accesses the database and queries, we have kind of a unit test that goes out and runs that to make sure that it works properly, that it assembles the dynamic query correctly and returns back the right record set. We have kind of a unit test for that because it's such a critical piece. So yes and no, I don't have it for everything yet, but for some critical areas, yes, we do.
All right. Well, Martin, thank you so much. That was really
Sure.